Morning, students.
Morning, sir.
Good morning, students. Can you hear me? Can you see the screen? Morning, students. Hello? Somebody needs to answer.
Morning, sir.
Volume is up. Just testing if you're hearing me, guys. Nobody's answering.
Yes, sir, we can hear you.
Somebody's talking, but I'm not hearing. Something is wrong. I'm not hearing. I'm not hearing. Hello? Speak again, please.
What did you say, sir?
Okay.
Yes, sir,
Now.
I hear you.
All right, cool. I think something is wrong with my device or whatever. All right. All right, guys. So we're gonna do some transformation revision. It's basically on the questions that I sent you the other day, and they are the most recent exam questions that we're gonna be doing. All right. I'm gonna start with this one on the screen, which is the May 2024 paper 2 exam. All right, that's what it is, May, June 2024. And the transformation question, this one, always is number 3, but sometimes they will also set one in section 2, the matrices question. Sometimes they use the application for transformation on the matrices question. But this one is not it. This one is straight matrices. So we're going down to number 3 right here. And I saw some solutions from some persons. Some persons got it right. Some persons made some mistakes, but that's what it is. Make mistakes, I learn from it. All right, so let's go. So this question is a diagram of shape T and an image Q. So it's as if this is the object and this is the image. So the transformation is from this one to that one based on what they have said. And after a transformation, they have not told us what the transformation is. And first part wants to describe fully, and with the word fully here means that we have to give the name of the transformation and the components of the transformation. You cannot just say what it is. And all you need to do, and I put in the must know sheet how you describe a transformation. I saw some persons describing and giving a long epistle that is not necessary. You basically just need to state the name and the components of the transformation. So for example, if you're describing a translation, all you need to do is say how many units left or right and how many units up or down. I can give the T matrix as well. For the translation, you can give the matrix with the value here and the value there. For reflection, all you need to do is say it's a reflection in which line. So for example, a reflection in line y equals x, a reflection in the x-axis, a reflection in the x in line x equals 1. You don't have to go about describing that orientation with the verse and all these things. Just give the name and the components. Look, it's only 2 marks for it, you know. They don't need an epistle. All right. If you're describing a rotation, remember, the rotation has 3 components. You have to give the name, rotation, the angle, the direction, and the center. Rotation has an angle of rotation. It has a direction of rotation. You can say clockwise or anti-clockwise. Remember, anti-clockwise rotation is positive. Clockwise rotation is negative. If you're not going to use the word clockwise and anti-clockwise. All right. And then you also have to state the center. That's when you're describing a rotation. If you're describing an enlargement, you have to give the scale factor and the center of the enlargement. Enlargement has two components. And that's why you basically describe those transformations. You don't have to delve into it any more than just giving the name and the components. All right, so for this one, what single transformation maps T onto Q? That's this way. Now, at first sight to me, right? At first sight, it looks like a reflection to me because I can see like the orientation is reversed. All right, so you can kind of double check it by giving the vertices some letters. So for example, if I go A, B, C, D, then this point is that one, A. Then on the long side here from the A is this point up here, B. Then across the short side, I'm going over to C. And then from C to D is this short side, this is D. So if you look at this one, the object, the orientation is this way, anti-clockwise that I just wrote. But if I look at that one, the orientation from A to B to C is this way. So the orientation is reversed. Remember, once the orientation is reversed, it means that you have a reflection in a line. You have a reflection in a line once the orientation is reversed. And the mirror line is going to be halfway between the corresponding points. So for example, these are corresponding points. So you know that the midpoint is the line is halfway between these 2 points. The line is like here. Similarly, these 2 points correspond. So if you join them, the line, the mirror line is halfway between them. So mirror line actually this line down here. That is your mirror line. That red line is a mirror line. Another way you can test it is if you know that this is the line y equals x, by the way, right? This is the line y equals x. It passes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So this line is the line y equals x. So this is a reflection line of y equals x. Now I tell you that you can know if the answer is correct. What do you know about reflecting the line y equals x? It's the same thing we did in functions. The xy point is reversed to a yx point. Let me write it down here. When you're reflecting the line y equals x, a xy point becomes a yx point. The more things you know, the better. Because remember, when we did functions and the inverse function, we said the relationship between a function and an inverse is a reflection in line y equals x. So it's the same thing that is happening here. So take this point, for example. It is 2, 1. 2, 1. The image point right here is 1, 2. You can say that that point is 1, 2. That confirms it. If you cut another point, say this point, for example, here, which corresponds to this one up here, this point is 5, 1. And the image point up here is 1, 5. So you see that the values are trading places, they are switching around. So that confirms it's a reflection in the line y equals x. And so we don't need to describe it. It's a reflection just as a mirror line. That's all we need to see. A reflection in the line y equals x. Just write it. Describe fully the transformation which maps T onto Q. It's a reflection in, or I can say over, in the line. So you give the name, and reflection only has one component, the mirror line. In the line, which line is that? In the line y equals x, and you are done. Get your 2 marks. 1 mark for saying it's a reflection, and the other mark for stating the mirror line y equals x. In the line y equals x. And that is it. You don't need to write anything more than that. Name and the components of the transformation. Better go with that?
Yes, sir.
All right, good. Next part says, on the same diagram above, we have to draw the image of triangle T, that's the image of this original one, after it undergoes a translation by the vector -1, 6. So the -1 is the direction that it moves horizontally. And when it's -1, it means it goes back 1. And this 6 is a dimension that a point will move vertically. So the points will move -1 back and 6 up. That's what a point on this image T will do. Remember, it's not going to turn or anything like that, you know. It's going to have the same shape, same dimension, everything. Just that the points on it will move. And what you generally do, you look and see what happens to one point. So take this vertex, for example. I'm going to do it in purple. Take this vertex, for example, this one. Let's say I'm going to use this vertex and do that translation on that vertex. It's going to move 1 unit to the left because of this -1 and 6 units upwards because of that 6. You want to make sure that the scale of the graph is 1 centimeter to 1 unit horizontal, which it is, and 1 centimeter to 1 unit vertically, right? So this point, 1 unit back will come to here. 1 unit back will come to here first. We're going 6 units up. That's 1, 2, 3, 4, 5, 6. So it means that this point is coming to here. Right? Let me draw this shape in blue. So that is coming to here. And then all I need to do is redraw this shape because of a translation. I just need to redraw this shape starting from this point. All right. So this side is 2 units down from this point. So it's going to be 2 units down from this point as well, like here. Then this horizontal piece is 3 units this way. So I just need to go 3 units this way here. 1, 2, 3. All right, so this side is coming right there. And then this piece is 1 unit to the left. That's right here. So this piece, the image of it is this. And then I join these two to connect there. So I join here to connect that. And that is the shape. Now, if you wanted, you could have done the translation on all the points, 1 unit back, 6 units up. But you only, with a translation, you will only need to do 1 point and just draw back the same shape around that 1 point. So this is the image, and this is where to label it M. And that is it. Any questions there? Any questions there?
No, sir.
Now we could also do some calculation on the point. I'm going to show you now. So this point, for example, let's calculate where that point would go. That point is 5, 3. This point is 5, 3. So we're doing 5, 3. And you add the translation matrix to it, which is -1, 6. Tells you where the image is going to go. It's going to add -1, 6. When we do this calculation, 5 and -1 is 4. 3 and 6 is 9. So it means that this point, which right now is 5, 3, remember we use a column vector for the calculations, it's going to go to 4, 9, which has a point is like this, 4, 9. So the image of this point is this point, 4, 9. We can confirm that this point here is actually, yes, 4, 9. Let's use a different color to show it. It's 4 and 9 up to reach that point, 4, 9. This point is 4, 9. Right? So the diagram and the calculations are consistent with one another. And that's the beauty about transformation. You can test your answers in multiple ways and know that you're correct. And that's what I like about it. Right? You can know that you are correct because the diagram and your calculations match. All right. So that is it. That is it. All right. So I've done that bit. And oh, it done. That's it. Nice, easy question. This one. It done. All right. Let's look at 2023. May 2023 next. Let's look for May 2023. All right. May 2023, right here. Okay. So it's supposed to be a nice, quick, short, efficient session today. We're just practicing, putting what we have done in the class to practice now. And all that needs to be done. So if you get something wrong, you go and redo it. And if you did not do a question, then you go and do it. All right. All mathematical principles can only be fully understood by solving many, many questions. So regardless of all the notes and explanation I do in class, you're really not going to fully understand these things until you start solving questions. And I don't mean watching me solve them. You have to absolutely do questions yourself. All right, so this question now gives us a trapezium E. This is trapezium right here on a square grid. And check the scale of it is 1 centimeter to 1 unit horizontally and 1 centimeter to 1 unit vertically. All right, so we can make sure of that first. Then it says on the diagram, you have to draw the image of triangle E after it undergoes a reflection in the line x equals -1, and we have to label it E prime. Let's do that one first. So if we're going to reflect in the line x equals -1, we have to draw it first. The line x equals -1. So x equals -1 is a vertical line passing through -1. We would have covered stuff like this when we did coordinate geometry. And that's the reason for teaching certain things first before we get to a topic like this. So you find that almost everything that we're doing in transformation, all the things we encounter, we already have the foundation, the tools to appreciate what they're talking about. So we should know that a line x equals -1 is a vertical line passing through -1 here. So let's draw that line first in blue. This is the line we're reflecting in. X equals -1. X equals -1. And one key thing that I always say is don't try to reflect the triangle over that line all at once. It's better to do it point by point, right? You tend to make mistakes when they try to reflect a shape all at once, all right? So don't reflect the entire triangle all at once. Let's do it point by point and make sure, all right? So these are the reading for the reflection. So this point here, for example, is 2 units to the mirror line. And so the image of that point is going to go 2 units on the other side here. All right. At this point, it is 1, 2, 3, 4 to the mirror line. So it's going to go 1, 2, 3, 4 to this side, to here. So this point is coming here. All right. So let's clean that up. And then this point is the same distance, same 4 units, 1, 2, 3, 4. So it is also going to go 4 units on the other side, 1, 2, 3, 4 to here. And see, it goes directly above this one because this point was directly above that one. Right? And you basically can fill it out now, but just to be safe, I'm just going to just make sure. And then this point is 1, 2, 3 to the mirror line. So it's going to go 1, 2, 3 on the other side to here. And so we have all the points that we need now in place, and we just join them to get that shape. Just join them to get that shape that I wanted. And that is it. And that is A prime, shape A prime. Just be careful and just make sure you get it right, guys. All right. It must look like a reflection. Remember, this must look like a line of symmetry of the object and the image of reflection. All right, everybody go do that one?
Yes, sir.
All right, good. Then we're going to do this one now. So we have another translation. But this time, the translation is 4, -7. This 4 means each point is going to move 4 units to the right And this -7 means each point is then going to move 7 units downwards. That's a -7. So a point here would move to here using this translation. Remember, you can also calculate, as I just did. But when you have the graph, it is much easier to just count off. Just count the 4 units to the right and the 7 units down. All right, rather than calculate. You don't need to calculate. All right, and it's well 1 mark for it. And again, because of translation, we can see what happened to 1 point and then draw back the same shape around that 1 point. All right, draw back the same shape around that 1 point. And let's use purple for this one. So here, remember we're doing at 4, -7, right? 4, -7. We're doing. So I'm going to use this point. So it's 4 units to the right. 1, 2, 3, 4, and then 7 units down. 1, 2, 3, 4, 5, 6, 7. So this point is coming here. All right, so that's it. I don't need these. Taking them off. This point will go here. 4 units to the right. 1, 2, 3, 4, 7 units down. 1, 2, 3, 4, 5, 6, 7. That's it. That's all I need to do now is draw back this shape around this point, where this point represents that one. So this line is 2 units this way. And then this line is 2 units up this way. And this line at the top is 1 unit this way. And then this diagonal piece the shape like that. And that is your image, A double prime. And just to confirm it, you can maybe do a little rough calculation on one of the points. So for example, we constructed with this point, but let's calculate with this point, just for example. So this point is -5, 4. So negative this point, I'm doing this point, maybe a different color. Let me use the blue for this point. I want to calculate for that point. So that point is the point -5, 4. So to calculate the translation on that point, we do -5, 4 plus the translation matrix, which was 4, -7, 4, -7. And we calculate this out. The -5 plus 4 is -1. And the 4 minus 7 is -3. So it means that the image of this point is at -1, -3. Right? Where the image of this point is this one. And that point is correct. -1, -3. So you can confirm the calculation and your diagram match. So you're good to go. And that's what you want to do sometimes. Just check consistency. So I tell you, this topic is beautiful because you can know that you're correct. You can check your answer with calculations and ensure that your calculations and your diagram match. All right. Questions like this, you want to make sure you get all the marks. So when you can do that, like a quick double check, you do it. All right. But good so far?
Yes, sir.
Let's go to that. All right. So anything else? No, this question finish. So let's see if there's any on the last question. There's a transformation on the last question. Let's see. All right, there you go. There's a transformation. So this question is helping you, and you don't necessarily get this help on all questions. This one is telling you that this matrix is for the anti-clockwise 90-degree rotation about the origin. But some questions won't give you that. So you can't assume that you'll always get this help. There are questions that will require you to know that that is it. And then this question is for friction in line y equals -x, which you should know. But again, it's better to know it, but some questions will not give it to you like this. Right? I don't know why they put them on this one, but not all the time they're going to put it. I will see that from some questions. Now this one says, determine the elements of matrix C. So forming a new matrix C, which is a single matrix, which represents the anticlockwise rotation of 90 degrees about the origin. This is the A now, the anticlockwise rotation. So that is A we're talking about, followed by, so A followed by a reflection line where it was made. That's B. A followed by B. So they want us to do A followed by B. So A followed by B. They say it is C, you know. The single matrix is C. And they say it is A followed by B. But we have to know that A followed by B is actually equal to BA. The second one times the first one. The second one times the first one. Just to get C, we need to multiply the B matrix by the A matrix. All right. So C is equal to BA. So therefore, the C matrix that I want is equal to the second matrix B, which is 0, -1, -1, 0. And I can tell you, I know the answer for this already. You know? I already know the answer for this. All right. You can know the answer for that because you have a reflection in this line and you have a 90-degree rotation. So you have a 90-degree rotation and you have a reflection in this line. So the other line that you're gonna get has to be at 45 degrees to this. The line, you're gonna get a line, you multiply them, the second one by the first one. Let me finish. The second one by the first one. First one is this, which is 0, -1, 1, 0. You're gonna get one of two lines. There are two lines that are 45 degrees to this. So either you're gonna get the y-axis reflection or you're gonna get the x-axis reflection. Right? Because remember, if it's a y-axis reflection, these two lines, if you reflect over them, you're gonna get a 90-degree rotation. Or it could be this line, x-axis reflection, because if you reflect over these two lines, you get in this 90 degrees rotation, depending on which one you do first. So I know my answer is one of these two matrices. Either it is the -1, 0, 0, 1 matrix for the y-axis reflection, or it is the 1, 0, 0, -1 x-axis reflection. Has to be one of those two. Those two lines are 45 degrees to the line y equals -x. All right, so that's what you want. You want to kind of know what the answer is supposed to be before you even do it. Mute the mic, please. Mute the mic. All right, so I'm going to multiply these out now. Remember this class, I'm not trying to teach you how to multiply matrices. No, would have already done it. All right, so how is it? It's a y-axis one, you know, because it's 0 times 0, which is 0, and -1 times 1, that's -1. So the answer is this one. All right, can almost just finish it off. All right, but let me just calculate it still. Then it's 0 times -1 is 0, and -1 times 0 is 0 for the value over here. And the value down here now is this row times this column, which is -1 times 0, and 0 times 1, which is 0. And then this last value out here is this row times this column. So it is -1 times -1 is a +1. 0 times 0 is 0, +1. So you see, you basically knew what answer you're supposed to get before you did it. Because you know that two reflections go with one rotation. Two reflections over intersecting lines is equivalent to a rotation. The rotation angle is twice the angle between the two lines. So if you have the rotation and you also have one of the lines, you know that the other line, the rotation is 90 degrees as it is here. And you have one of the lines, the other line must be at 45 degrees to this line. Because the rotation angle will always be twice the angle between the lines. You know those things, the questions get easier. You have confidence in the answer because you know what you're supposed to get. All right, so that is the C matrix. And you see, it's asking us to describe it. Describe geometric transformation C. So you see, this one, even though they give you these two, the description for these two, they didn't give you the description for this one. So you have to know it. So it's a nice question. You know. You had to know that A followed by B is equal to BA to get this. And then you have to know what reflection, what transformation that is. So reflection in line y equals x. See how they describe this one, guys? So I was telling you. I was telling you how you describe a transformation. You just need to give the name and the components. Let's look at how they describe it in the question. This transformation, how they describe it, it represents an anticlockwise, that's the direction. The name of the transformation is rotation. It's one component, the angle, the direction, sorry. And this is the center. This is the angle right here. And then this is the center. Because the rotation, it has three components. 1, 2, 3. That's all they did in describing that transformation. They give the name of it and the three components. Then for this one, which is a reflection, how did they describe it? They give the name reflection and they state the mirror line, one component. They state the mirror line. Reflection only has one component. A reflection in the straight line, y equals minus x. So this is an example. So if CSEC, their question can describe it this way, then this is how they expect you to describe it as well. So you don't have to go writing anything big and long. Just give the name of the transformation and the components of the transformation. So persons who are trying to like teach what a transformation is in their description, you don't need to do that. Just give the name and the components as they have done here in this question. All right, and now we know that this is for a reflection in line y equals x. So this is going to write about just like that. All right, so transformation C is a reflection in the line y equals x. All right, describe geometrically single transformation C. All right, so C represents, I can say C is, they'll accept that as well. C represents a reflection in the line y. Oh, no, line is y-axis, right? It's a y-axis we said, right? Y-axis, sorry. It's y-axis. It's a y-axis. So we can say the line x equals 0. And y-axis is x equals 0. In the line, x equals 0. But that line is actually the y-axis. So the reflection in the y-axis, which is the line x equals 0. But go to that?
Yes, sir.
All right, I think this question finished. All right, because down here, would have done it in transformation, right? In matrices. So I'm not going to focus on this question down here. Let me see. Oh, it's a transformation still. It's a transformation still, sorry. It says transformation T is defined by the 2 by 2 matrix, this one, where K is a constant. Okay. It says T is mapped. T, let's go again. Transformation T is defined as a 2 by 2 matrix T. So that's a transformation T. It says T maps this point onto this point. I don't want us to find the value of K. What it means that when you apply the matrix to this point, you'll get that point. That's what works. All right. So it's like setting up an equation that you're trying to solve. When you apply T to this point, the answer is that point. That's what the basically means. So let's set it up like an equation. It means that 1, 2, K minus 1 times this point. The matrix for this point is 2, 3. It is equal to the matrix for this point, which is 8, 15. And you'll find that when you multiply this row by this column, you get in the 8. You'll see that, because to get this 8, it will be 1 times 2, which is 2, plus 2 times 3, which is 6. That is what I get the 8 up here. So you don't have a problem on that line, right? You really want to find the K. So to find the K, you need to be working this row I'm writing the work in this row with the one column equals this 15. That's what you're setting up, all right, to get the key. So it is a k times 2, first element times first element. K times 2 is 2k. And then the minus 1 times 3 is -3. That is what is equal to this 15 over here. So that's what it's solving. If you add this 15 over here, add it, it becomes 18. So 2k equals 18. And then divide by this 2, the k equals 9. So then says that k is equal to 9. What do we go to that? But okay?
Yeah.
All right, so that's a nice question. Somebody have a question? Very good. All right, sounds like everybody good. Anything else? All right, so this is vectors. This is the topic we're going to be doing next week after we finish transformation. All right, that finishes June 2023. All right, let's go to June 2022 now. June 2022. June 2022 next. 2022. So when it's going to do the June one, and we're going to come back and do the January ones. All right. So 2022 June, right here. I think I gave you the papers down to 2021. Gave you 8 papers to do. All right, let's go. So the transformation question is always number 3 on the new syllabus, the syllabus that you are doing. There you go. Here it is. All right, so let's see what this one says. This one says diagram below shows 4 shapes, PQR, and S. So that looks like the original one because that's the only one that is shaded black. All right. It says, describe the single transformation, right, which maps P onto each of the others. All right. So we're doing P to Q first. P to Q. That's this one to this one. Well, that to me is a rotation. It's a 180 degrees rotation. All right. Because this piece here, one is 180 degrees. This piece, for example, was pointing this way on the object. It is now pointing that way on the image. All right, let's do another side. This slant piece from the point up to here was pointing this way. And now from the point down to here, it's pointing that way. So you see it like this rotate 180 degrees around that way, right? Now looking back at the original piece, this one, rotate it to there. Rotate it to there. So that this turn all the way around. So I know that the angle of rotation is 180 degrees. And the direction, because it's 180 degrees, it can be anti-clockwise or clockwise. Those make a difference because it's 180 degrees. So the next thing we need is the center. Remember, rotation has 2 components. It has 3 components: angle, direction, and center. So I already know it's a rotation because it turns all the way around, right? And it's a 180 degrees rotation. And the direction is clockwise or anti-clockwise, right? So we have the direction, doesn't matter, because 180 degrees. So we need the center now. We need the center. All right, so how do we find the center? You can find the center because they are joined, right? Because they are joined. You know, the center point has to be somewhere on this line. And the center of rotation is always going to be invariant. Remember, we said that. Because if you have a shape like this, for example, and you're rotating about here, up this way, then it's going to come to here. Right? So the center of rotation is invariant. It's invariant. So looking for the point on this that did not change. Now, all the points over here change, you know, because they are now here. They are now here. All of those change. So points that did not change is on this line. But be smart. This point changed to here. So that's not an invariant point. The invariant point is actually right here. That's a point that didn't change, that didn't move. So the rotation took place around that point, and you can actually test it. Because, for example, if you join here to here to find the center, you're going to see that this is the center of the rotation. If you rotate this point 180 degrees around here, and if you choose another point, like for example, even this one here, or if this one, go back for the red, and say even this one corresponds to this, or even this one, these two, then when you join them, you basically say that this point rotated around to here. You see that again, this is the center of the rotation. So this is the center of the rotation. All right, what is that point? That point is 7, 7. That point is 7, 7. That blue point, that center of rotation is 7, 7. So this we can say it is a clockwise 180-degree rotation about the point 7, 7. You have to stay at the center of the rotation. But I go to that. As simple as this is now, this question gave some people problems and gave some persons problems. So this is the center of rotation right here. All right, so that 180 degrees, let me draw back this line. So you can see that I rotate 180 degrees. 180 degrees. All right, I want to see clockwise. Could have said anti-clockwise as well, but I'm just going to say clockwise for no particular reason. All right, but I'm going to make sure that I give a direction. So shape that map, transformation of map P to Q is 180 degrees clockwise, just to make sure that I give a direction. Rotation, that's the name of the transformation. You make sure you put it in there. About the point. And the point is 7, 7. So I've given the name and the 3 components: angle, direction, and center. Make sure all 3 components along with the name are written in your description: angle, direction, and center. Some persons actually just list them. You see the rotation, let's say angle 180 degrees, direction clockwise, center 77. Some people actually list it. 3 marks for it, and I think it's 1 mark for each. All right, so what is it? Maybe there's a mark for saying it's a rotation as well. I don't know, but you have to give the 3 components if you want to get the full marks. All right, I mean, because of 180-degree rotation, it don't matter if it's clockwise or anti-clockwise. Maybe they're not giving any marks for direction, but give a mark for the name and these 2 components. But I want you to still get into the habit and the practice of giving rotation 3 components. All right, so far as I go to that one. Very good.
Yes, sir.
All right, we're going to look at those to R now. How do we go from P to R next? P to R. So let me take these off. Going from P to R. So from this one over to that one. That looks like a reflection to me. And I can see that the orientation is reversed. Right? Orientation is reversed. Because if you take, for example, this point as A, this point as B, and this point as C, that's going now A, B, C. This was anti-clockwise, and this is now clockwise. So the orientation has reversed, and so on was a reflection in a line. All right. Now, once I know it's a reflection in a line, I just need to know what the mirror line is, because reflection only has one component. And the mirror line is going to be just halfway between corresponding points. So this line, these 2 points are corresponding points. So the mirror line is halfway between them, 1, 2, 3, 4. So the mirror line is going to be right here. You want to charge up? The mirror line is going to be right here. Right halfway between them. This is the mirror line. This is your mirror line right here. All right. And if you choose another point here and here, for example, that's 1, 2, 3, 4, 5. On the other side, it's 1, 2, 3, 4, 5. Good. So that mirror line is the right place. I just need to give it the equation of it now. It's a vertical line passing through 1, see? And so that line is x equals 1. And so to describe it, we just need to say it's a reflection in the line x equals 1. That is all. So this one down here is a reflection in the line x equals 1. A reflection in the line. Reflection in the line x equals 1. All right, that is it. Now, some person might think that this is a rotation, you know. I think it's a 180-degree rotation because this side seems to turn around. But not a rotation because we tested the reversal of the orientation. And once the orientation is reversed, it is not a rotation. It's actually a reflection. All right, if it's a 180-degree rotation, then the image would have looked like this. It would just have to be somewhere else. So it's rotated about some other center than this one. All right, but that is it. So that is that one. But go to that. But okay.
Yes, sir.
All right. So the next thing now is how do we go from P to S? So now we're going from P to S. Now clearly that's an enlargement, guys. It's an enlargement. All right. We can decipher some things about the enlargement right away. So it's an enlargement. We can actually see what the scale factor is. So this side, for example, here was 1 unit. It's now 2 units. From 1 to 2, it means that the K is 2. So multiply by 2. You want to choose another side. Like for example, here, this was 2 units. It has grown to 4 units. It means that you multiplied by 2 to go from this side to this side. So the scale factor is 2. Scale factor is the value that you multiply the dimensions by. All right, so that's the first thing. Additionally, the positive scale factor. Scale factor is positive. How do I know it's positive? Because the image and the object, they are pointing in the same direction. So this side, for example, on the image, it's pointing this way. On the object, it's pointing the same way. So it is not inverted. If the scale factor was negative, then it will be inverted and the points on the image will be pointing in the opposite direction from on the object. So when it's a positive scale factor, but they're pointing in the same direction. So we have a scale factor part, we have a scale factor down part. What we need to find out is the center of the enlargement. Center of the enlargement. The center of the enlargement is the easiest thing to find. You just need to join corresponding points, 2 different corresponding points, and find where those lines meet. So for example, here and here are 2 easy corresponding points on this object and this image. Right? That object and this image, this enlarged image. Right? Those are 2 corresponding points. I'm going to join them straight lines. That's straight line. So you know that the center of enlargement is on this line. What's happening here, Mr. Shaw? Center of enlargement is on this line. If I join these 2 corresponding points, I need 2 more to join. So for example, I can join this one and this one. and just extend it back. So 1, 2, 3, 4, 1, 2, 3, 4. So it looks like it goes like that. So those two. Join these 2 points and extend it back. So the center of the enlargement is right where these 2 lines meet. We can check if the center of enlargement is correct. Remember, the scale factor of 2 also affects distance from the center point. So for example, the distance from this point to this point is 3 units, 1, 2, 3. But from this point to the image of this point, it should be double to 6, which is 1, 2, 3, 4, 5, 6. So looking good. Let's choose another point. Let's say to this point, which corresponds to this point. So the straight line would have taken us through there too, but we can check if the scale factor is working. So this distance here would have doubled to this distance here. The question is, what is this distance? Now you can break down this distance. Let me take this off and show you how you can break down that distance. So I want to test if this distance is doubled to here from this center point. So you see this distance, I can break it down into horizontal and component. So I can count how many units this way and how many units that way to represent the length of this line. So this is 1, 2, 3, 4. And this is 1 to here. This side is 3. So the 4, 3 line. Let's call it that way. So the length of this line can be broken down into vertical and horizontal components. 4, 3. So basically, to come to this point, this 4, 3 is supposed to be doubled to 8, 6 from here. So see that works in purple. So like you come down here, so 8. Come down here, 8. And it's supposed to go 6 across here to reach here. So the scale factor is actually 2. And this is the true center. Then this 4, 3 representing the length of this line or the components of the length of this line. Supposed to double out to the length of this line now to component 8, 4, 8, 6, sorry, 8, 6. So this purple line is supposed to be now 8. And this horizontal line is supposed to be 6. We drop the scale factor of 2 on it. So let's check it. 1, 2, 3, 4, 5, 6, 7, 8. Good. And then across it is 1, 2, 3, 4, 5, 6. Good. So I am confident that this center point is correct, right? And that I've described it properly. This is the center point, which is at 7, 11. So the center point is at 7, 11. I've done my checks and I know that it is correct. Well, let me just draw about these construction lines. So I join this point and extend it back up to here. Then I join this point and this point, which are corresponding points, and extend it back up to there. And that's how we got this as our center point. And then we just use and check our scale factor. That point, as I said, is 7, 11. We'll describe that enlargement by giving the scale factor over here and the center over here. All right, so that is it. So, you know, P is marked onto S by an enlargement of scale factor I can put k equal 2 or 2. I'm gonna say about to say that the point 7, 11 is a center, say about the point. As a center point, you enlarge about a point. And the point we said was 7, 11. About the point 7. I could say scale factor 2 and and center 711. We say that an enlargement of scale factor 2 and center 711. We could say that as well. We say that as well. But I go to that. Are they okay? Hello.
Yes, sir.
All right. Next question wants us to do a translation. They always like to give us translation. I don't know why, but they give us other stuff sometimes, enlargement and other stuff. So because of these series of questions, all of them giving us translation. This is not to say they only give translation, guys. They give other transformations as well. Hopefully we'll come up on one, but we're definitely gonna do a lot of them in this program. All right. So question says on the same page, we have to draw the image of same P after a translation -2, 3. So -2, 3 means if a point is here, it's going to go 2 units to the left because of this -2, 2 units to the left, and 3 units up because of that 3, +3 to here. So points going to here like that. 2 units to the left and 3 units up. So let's do that with 1 point for the translation and draw by the same shape around the point. We're doing it on the same P, all right? On the same P. On the same P. So let me take these off now. All right. So let's do this point right here. That's the way it goes. And let's draw about the same shape around that 1 point. So it's 2 units to the left. What is it again? Let's make sure -2, 3. So doing translation -2, 3. So we're going to move it 2 units to the left. 1, 2 to here. And then 3 units up. 1, 2, 3 here. So this point is going to there. And make sure, see, 1 centimeter on the scale is 1 unit. And 1 centimeter up is also 1 unit. So that is it. 2 units to the left. That's a -2. And this is a +3 up. So this point is coming here. So I'm going to draw about the same shape around that point, around this point. So this point is here. So this side is how many units? 1, 2, 3, 4 units long. So 1, 2, 3, 4 units long. And then this side up here is 2 units. 2 units. This piece at the top is 1 unit. 1 unit. Then 1 unit down here. 1 unit down here. Then 2 units at the top here. 2 units at the top here. Then it finishes off with this little diagonal piece. That little diagonal piece. And that is our image of the translation. What did they say to name it? They said to name it T. All right, so we're going to put a T on it. And we are done. That is it. But after that, very good.
Yes, sir.
All right.
Yes, sir.
Beautiful. All right, so that was that question. Though they give a transformation and a full transformation question. Let's look over on the last question to see if they give us any transformation application and image to see. Let's see. Yes, they did. Wow. See, 2 transformation questions. I tell you guys, I told you that cannot. So you see what I told you in class, bearing fruit. This was just in 2022. I did tell you that you can get 2 transformation questions on the paper. This one is a transformation question. Really made to see, but they're applying transformation to it, right? This point looks so familiar, 711. Didn't you just use a 711 a while ago? Let me see. 711, look at that. Wow. What a coincidence. All right, let's see. All right, let's see. All right. So here again, they're helping you. They give you the matrices. So transformation A is this one is the anti-clockwise 90-degree rotation matrix, which you should know about the origin. So they're helping you. They give it to you. It won't depend on that though, guys. And this one is a y equals minus x reflection. Here, there it is. Reflection in the line y equals minus x. It says write down coordinates of P prime, the image of 711 after it undergoes a rotation of 90 degrees anticlockwise about the origin. So we can do that by applying this matrix to this point. Apply the rotation matrix to the point. All right, so it's going to be basically A times P equals P prime. The transformation matrix is A. When you apply it to the point P, the image is this P prime that they're asking you for. So the matrix is 0, minus 1, 1, 0. I apply to the point, which is 7, 11. I work out what the P prime is. So it's 0 times 0. 0 times 7 is 0. Negative 1 times 11, that's negative 11. And then 1 times 7 is 7. But this 0 times 11 does not apply, so it becomes 7. This is a P prime. We have to write as coordinates. So you cannot leave it like this, because I said coordinates. This is where you write coordinates. P prime, and you put the values in there. Negative 11, 7. So this is your answer. Not this. That's just a calculation. This is your answer. This is a matrix, the vector for the point, the position vector of the point. I want to see that when we do vectors. But this is the coordinates of the point. I have to answer and give them what they want. All right, that is it. But good at that.
Yes, sir.
All right. Next thing I want us to do T. It's like T is the combined. So given us another transformation T now, similar to the one that we did before. T is a combined transformation A followed by B. Determine the elements of the matrix representing transformation T. So it's what it is that T is this matrix. A followed by B. So T, remember, A followed by B is B times A. A followed by B is BA. Second one times the first one. So we have to multiply the second transformation by the first one. All right, so the B is this one, which is a reflection line y equals minus x, 0, minus 1, minus 1, 0. And then this now is a clockwise rotation, 90 degrees, 0, minus 1, 1, 0. Okay, work out what we're supposed to get again on this, right? So if you think about it, you have y equals minus x line, and you have a rotation, anti-clockwise rotation this way. So the 90-degree rotation and line y equals minus x. So the other line that you're trying to get the majority in red has to be at 45 degrees to this. So the lines that are 45 degrees to this is either the x-axis or the y-axis. So it's one of those two lines that are 45 degrees to that. So the answer for this is supposed to be either the matrix for reflecting in the y-axis, which is minus 1, 0, 0, 1, or the matrix for reflecting in the x-axis, which is 1, 0, 0, minus 1. Your answer is supposed to be one of these. All right, let's work it out. So going back for the blue, you're going to get a 2 by 2 matrix. And it's 0 times 1 is 0. And then minus 1 times 1 is minus 1. So it turns out that's going to be this one is the answer. All right. And then the value over here is this row times this column, which is 0 times minus 1 is 0. And minus 1 times 0 is 0, which is what you expect to get. And the value down here is this row times this column. So again, it's going to be 0 because it is negative 1 times 0 and 0 times 1. That's a 0. And then the value down here is this row times this column. It's going to be 1 because it is negative 1 times negative 1 is a positive 1 and 0 times 0 is 0. So you see, you get the answer that you're supposed to get. And here again, they're asking you to describe it, see? So you have to know the matrix to describe it. So reflection in the line y equals reflection in the y-axis, right? You can write that a reflection in the y-axis, or you could say the line x equals 0, or the y-axis is a line x equals 0. That is it. What good at that?
Yes, sir.
All right. Let's continue. Continuous 2 by 2 matrix C. Scalar, say it's singular. So you should know this. You do this already. This product equal this product when it's singular. In singular, it has no inverse. It has no inverse. And that's because the determinant is equal to 0. And that means that this product and that product is the same. So when that happens, the 6 times k, which is this product, is equal to the 3 times 4, which is this product. And this is at 12. So for this to be 12, the k has to be 2. All right, but I don't want us to do the matrices. That finishes that question anyway. All right, that's 2022. Let's go to, hold on a second. Okay, let's go to 2021. 2021. 2021. Right, where are you? Right here. All right, 2021, number 3. Let me go a little bit faster now. I see that's basically the same thing they're asking. All right, let's look at this one. All right, part B. All right, so part B is a transformation of this one. So it says, the diagram below shows 3 triangles, X, Y, and Z on square grid, right? Those are 3 triangles, X, Y, and Z. So clearly some transformation taking place there. First part says triangle X is mapped onto Y by a reflection. So they're telling us it's a reflection. State the equation of the mirror line. All right, that's X to Y. Let's look at it. So the mirror line is halfway between them. This is this one to this one. And I want the equation of the mirror line, you know. The equation of the mirror line. Because it looks like the x-axis from this to this. Halfway between these points is this line. Right? Halfway between these 2 points is this line. So this is the mirror line, x-axis. X-axis is the line y equals 0. And that's why I put as the answer, you know. Y equals 0, because I asked for the equation of the mirror line. So here, the mirror line is the x-axis. Equation is y equals 0. Equation of x-axis is y equals 0. This is the answer we're looking for, not x-axis. X-axis is not an equation. So careful with that. So I spoke about that in class a lot. The equation of x-axis is y equals 0. The equation of the y-axis is x equals 0. Here it says, now describe fully transformation that maps now x to z. X to z. X to z. Let's look at it. X to z. That's this one to this one. All right, let's analyze it now. So this one, I know that there's a turn. All right, x to z. Let's analyze it. So take this side, for example. Let's start pointing it this way. That line is now pointing this way. So it means that it turned up. So 90 degrees. One was 90 degrees because initially it was horizontal. It's now vertical. So if you turn from horizontal to vertical, it means that it turns to 90 degrees. So I know it's a 90-degree turn. All right. And we can say anticlockwise. You can say anticlockwise, but you think of as if this point turn up that way, be facing that way now. It's the anticlockwise rotation of 90 degrees. And it's 90 degrees, as I said, because piece of it that was horizontal is now vertical. All right. So we know the angle, I know the direction. The question now is what is the center? Now, most times the center is the origin. Remember, I showed you we can find the center by finding the perpendicular bisector of lines joining corresponding points. So for example, you could join these two corresponding points, and then you want a perpendicular bisector. So perpendicular bisector will be this midpoint is the midpoint. I want a perpendicular to it. That's one. Perpendicular bisector of lines joining corresponding points. And then you could maybe join 2 points now, this one and this one. Join both of them. This is it again. Join both of them, corresponding points. And then find a midpoint between them, which is the y-axis right here. Because this is 1, 2, 3, 4. 1, 2, 3, 4. So the midpoint between those 2 points is the y-axis, right on the y-axis here. And then perpendicular. This line is horizontal, so the perpendicular is going to be the y-axis. So those 2 blue lines are my 2 perpendicular bisectors. You see that they meet at the origin. So this is the center of my rotation. That's doing it by construction. But most times the center of the rotation, is the origin. I can do a quick check like this. So a quick check that I can do is for example, this point, you're making the coordinates out to this point. Is that this point was rotated up to this point. What should that mean is that these coordinates, this L-looking thing, has to be rotated 90 degrees as well. So this horizontal piece on the x-axis, if you rotate it 90 degrees, it's going to come up on the y-axis here. And this piece at the head of it, if you rotate it over so, it's going to go now horizontal, right? It's now vertical. If you rotate it 90 degrees, it's going to go horizontal. So you see here we have rotated this L that is forming the coordinates 90 degrees up to here. That is consistent with this being the center. If it works for another point, then you're good. Let's choose another point. Let's just choose this point right here. Coordinates of this point is just this vertical line right here. Rotate that vertical line 90 degrees clockwise. It's going to come down to here, which again is consistent because this point corresponds to this one. And so that is kind of confirming that the center, the rotation is the origin. So most times it is the origin. I can just do like the quick check with the L's, the L for the coordinates. That's like the coordinates, or you get to the point using the coordinates and rotate it as well, just to confirm that it is 90 degrees. All right. So it's a 90 degrees anti-clockwise, it's a 90 degrees anti-clockwise rotation about the origin. That's what it is. From X to Z. Anti-clockwise 90 degrees rotation about the origin. That's right. And anti-clockwise. Anti-clockwise. -90 degrees rotation. Rotation about the origin. Remember, anticlockwise rotation is positive rotation. So instead of saying an anticlockwise 90 rotation, you could have said a positive 90-degree rotation. 60 would have to give you the marks. But safe thing to do is to spell out the word anticlockwise. But remember, anticlockwise rotation is positive rotation. All right, so this anticlockwise rotation of 90 degrees will be the same as saying positive 90 degrees. Well, let's check if we give the three components. So I've given the name, which is rotation. I've given the angle, I've given the direction, and we have stated the center. So that description is complete. All right, that description is complete. All right, very good with that.
Yes, sir.
All right, good. Next thing, I want us to do this translation again on y negative 7,1 and label the answer V. So negative 7,1 means you're going to go 7 to the left. That's negative 7 from a point and 1 up. That's 1 up this way. All right. That's what we're going to do. Negative 7,1. We're doing it on triangle Y. All right, let's go. Which is this one, triangle Y. 7 to the left. So this point, we're going to do this point now. So I use the point to do. So this point is at 0 on the y-axis horizontal. Negative 7. Going to bring it over. Now 7 to the left, going to carry it over to negative 7 over here. To here. 1, 2, 3, 4, 5, 6, 7. All right, so that's where it's going to go first. And then it's going to go 1 up. That's negative 7, 1. Going to go 1 up to here. So negative 7, that's a negative 7. And then 1 up. So it actually comes to this point. So let me take this off. Negative 7 and 1 up. So it's coming to here. So it's a 1 up. So this point is coming to here. So all I need to do is draw back this same shape around that point. So let's do it in blue. So I'm going to draw back this horizontal piece first, which is 1, 2, 3, 4, 5, 6 units. 6 units. So it's 6 units over to here. 1, 2, 3, 4, 5, 6 units. That's that piece. And this slant piece, I can get it by doing 2 down, 2 back to go from here to here. So 2 down, 2 back. So 2 down, 2 back. So this point is coming to here. I could count it off still from here to here. The negative 7, 1 up. So it will go 1, 2, 3, 4, 5, 6, 7, 1 up. So that point is there. And then all you have to do is complete the triangle now, like that. All right, let me take all these red marks. That is it. So let's almost leave it again. Label it double, right? No, label it the V. Label it the V. V. All right, that is that. All right, next part now says on the same diagram, enlarge triangle X with center 0, 0, scale factor half. Remember, when the center is 0, 0, you can use the matrix K, 0, 0, K. In that case, scale factor is a half, so it's half, 0, 0, half. Remember, I said the enlargement is the easiest one to do because all you need to do is multiply the coordinates by the scale factor. So a point XY, for example, will go to half X, half Y by calculation. So we can use that quick, easy method to do it. just half the coordinates for each point, and you have the image under this transformation. Scale factor half, and the center is 0. So the image is going to be half the size and half the distance from the origin. Right? So you need the half the coordinates to get it. Which one we're doing that on again? We're doing it on X. We're doing it on X. So this is the X and half the coordinates from here. So this point is 1 unit. 2 units away is going to come to 1. So this point is coming to here. 1 unit, half it. This point up here is 4, 4, 4, 4. It's going to go to 2, 2, half the coordinates. So this point is 4, 4. This point is 4, 4. It's going to come to 2, 2 right here. So this point is coming right here. And then this point out here, it is what? 6, 2. 6, 2. So it's going to go to 3, 1. 3, 1. 3, 1 right here. From this origin. We put origin in a different color. In red. So the image triangle is that it's on these 3 blue lines. The vertices. These are the vertices of the image of the enlargement of scale factor half. That is it. That is it. And these are construction lines, for example, out here, out there, and up here. And that's how it looks. I don't need those red lines. I'm just showing you them as a construction lines. All right, but that is it. But that is it, guys. That is it. I have to do the mathematics easily. So in the center of the enlargement is the origin. You have a scale factor. You just need to multiply the coordinates by the scale factor. Easy. And then someone label this one what? W, I think. W. W. This one was W. W. This is it. Any question there? Very good. Students, good? Half an hour left.
Right.
Not yet. Okay. All right. Let's finish it. Let's finish it. Let's finish it. Yes, that finishes this one. All right. So let's jump to January now. Do a couple from the January paper. I'm gonna maybe go a little bit faster and try and get through all of them. Right. So basically 4 more in half an hour. All right. So let's go. I'll go to the January paper and do them in January 2024. Let's see. Let's see. It's 3. There you go. All right, let me pick up the speed a little bit more. So we can get through these 4 more questions. All right, 24, 23, 22, 21. All right, diagram below shows 3 triangles P, Q, and R. Q and R are images of P. So this is the original one, right? And this is marked to those 2. All right. Undergo a double transformation. Okay. So it's images of after it undergoes a double transformation. So like 2 transformations take place. So maybe we'll go to this first and then from that to that. But let's read. It says, describe fully the single transformation that maps P onto R. So from this to this. Now, if you look at it, the shapes are exactly the same. There's no turning, there's no change in size. So we have a translation right there. Move from one place to another. So for translation, we just need to count off how many units horizontally and vertically moved. I just need to look and see what happened to one point. So for example, here and here are corresponding points. Don't try to determine it from the entire shape. Choose 1 point. So this is 2 units to the right. So the translation matrix would have a 2 on that value. And then 1, 2, 3, 4 units up. So the translation 2, 4. Simple as that. You're not sure, you can check another point, like maybe this to this, just to confirm it. All right, so it is 2 units to the right, yes. 1, 2, 3, 4 units up, yes. So it's translation 2, 4. All right, so we can see that P to Q, 1 point to Q by translation given by 2, 4. Or I could say 2 units to the right, 2 units to the right, and 4 units upwards, 4 units upwards, upwards. So you could say this instead. Instead of writing the matrix. I think the matrix is pre-created it. They'll accept that. It's a translation given by 2, 4. And then we're going now from R to Q. So you see, not P to Q now, R to Q. So went from this one to this one now. And that's a reflection I can see. As the orientation is reversed, I can see it. So for example, I know the orientation reversed. If we choose this point as A, this point as B, and this point as C, then that corresponds point here is A. This point up here is now B prime. And this point here is now C prime. So this orientation is anti-clockwise, but this one is now clockwise. So I know it's a reflection in a line. All right. And when it's a reflection in a line, the mirror line is halfway between the corresponding points. So for example, these are corresponding points. They are 1, 2, 3, 4 apart. The mirror line is halfway between them right here in red. Because it's the same thing happening with these 2 points up there. So the mirror line is that red line, which is a vertical line passing through 1, right here, the 1 on the x-axis. That is x equals 1. And so we have a reflection in the line x equals 1. All right, so that's a reflection in the line where x equals 1. So we have a reflection in the line x equals 1. Done. That's it. All right, just and done. Nice and easy, quick and fast. Nothing complicated. All right, let's see if there was any on number 10. Let's see if there's any transformation on number 10. Let's see vectors. No, this was straight matrices, not a transformation. All right, done. Let's go to the next one. 2023. 2023. 2022, sorry, 2022, we need next. Right here. That was our rest of the 2020. Where's the 20? Yeah, let's skip over 2023. Let's go back. It's 2023 we need. January 2023. Where's the 24? We don't need 2023. Just can't keep over that one, man. That one is a nice one. That one is a nice one. Yes, that's the year we just set the rotation. I give some persons problems to do. All right, so let's see. Yeah, okay, we'll be skipping over this one. Like crazy. Yeah, I'll skip over this one. There you go. All right, let's go. So this one says, following diagram shows three quadrilaterals, P, Q, and R, on a square grid. Q and R are image of P. So Q and R are images of P. All right, so this is the object. And you go into that, I go into that, all right? So this one appears the object with an O on it. All right. And two different transformations. Well, this one clearly is an enlargement, obviously, right? This one looks like a rotation. This piece down here was horizontal, is no vertical, sorry, is no horizontal. But let's go one at a time. Question says, on the grid, draw the image of P, translation 10, -4. So 10, -4 means 10 to the right and 4 down. 10 to the right, 4 down. All right. So we're doing that on P. 10 to the right and 4 down. So we're doing it on this one. Just need to see what happened to 1 point and draw the remaining shape around it. So let's do it for this point. 10 to the right, 4 down. So if we are at -7 over 10 to the right, we're going to go all the way over to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. From -7, we go 10 to the right, we're going to come over to 3 right here. And then 4 down. So if we are up at 7 here, we'll go to 4 down, we'll come down to 3. Right there. 1, 2, 3, 4. Good. So this point up here is coming to here. And then all we need to do, that's 10, 10, -4. To go from here to here. And then draw the same shape around that point. So we have these two diagonals, which is here and there. And then from here, it's basically 2 down, 1 back. All right. Or you can say the middle line is 3 units, 1, 2, 3. So if we do that, 1, 2, 3, it's coming down to here. So coming down to this point. So this is it. Same shape. And this is supposed to be P prime, let's say, right? P prime. That is it. Do I go to that? But okay. So take out these red lines for the other part. So that is it. That's P prime. The next thing I want us to do is to reflect in the line y equals 0. You have to know that the line y equals 0 is actually the x-axis. That's a key thing here. Reflect the triangle P in the x-axis, and that's it. Going to be P double prime. All right, so we're now reflecting in this x-axis, the line y equals 0. That's the line y equals 0. X-axis, let's make sure that what I said, yes, y equals 0, x-axis. And reflecting in that line, reflecting this in the line. So for that one, now we're gonna do image distance equal object distance and do it 1 point at a time. All right, so this point, for example, is 1, 2, 3, 4. It's gonna go 1, 2, 3, 4 to here. And then after that, this point up here is 1, 2, 3, 4, 5, 6, 7. So you're gonna go 7 on the other side. So this is gonna 4 down to here and then 3 more. 1, 2, 3 to here. So that's 4 and 3, 7. So this point coming all the way down to here. All right, so far so good. Those are 2 points so far. And then this point now, and this point, they're going to same distance. It's 1, 2, 3, 4, 5, 6. So going 1, 2, 3, 4, 5, 6 to here. And right across from it, you have this one as well. Here. So those are your points. I'm just showing them to get the image. And that's our Peter prime. This is Peter prime. But okay with that?
Yes, sir.
All right. Then now we're gonna have to describe now. Describe fully, and I want a single transformation, guys. A single transformation in bold letters, which maps P onto Q. P onto Q. That's this one to this one. Now that clearly is an enlargement. All right. All right, so we can go with the scale factor now. We can choose one side. So for example, across here, it's 2 units. And across here, that becomes 1, 2, 3, 4, 5, 6 units. So that's a multiplier by 3. We go from 2 to 6. So the scale factor is 3. It's a positive 3. How do I know it's a positive 3? They're pointing in the same direction. So on the image, this long side, this long diagonal in the middle is pointing down like that. And the corresponding side or piece in the middle here, or diagonal in the middle here, also pointing down. So it's a positive 3 scale factor. Let's make a note of it. A positive 3. So the K is a positive 3. I can just write 3. A positive scale factor of 3. Image and object point in the same direction as a multiplier by 3. All right. Now we could look at it. This diagonal is across one box. This one is across 1, 2, 3 boxes. 3 boxes versus 1 box. So anyway, we'll look at it. Scale factor S3. Remember, though, that the scale factor also affects distance from the center of the enlargement. I want to finish describing it or finding the components until we find the center. The center of enlargement is the easiest thing to find. You just need to join corresponding points and extend them back until you locate them. All right, so let's do that. So the two easy corresponding points to join are these two first. So you know that the center of the enlargement is somewhere on this line. Then I can join this one and this one. And that's straight across here. Visual and draw straight across here. And it looks like this point. Let me draw it over. Join these 2 points and extend it back. Corresponding points. Looks like this point out here is the center. And I want to check it if it is correct. Right? Working the scale factor 3 on it. All right. So this distance right here, you know, to that original point is 3 units long, right? 1, 2, 3 from the center. This is the center. This is 3 units long right now. If that is the correct center and I apply this scale factor on it, it's supposed to push this point to 9, which is 9 from this center. So let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9 out to this point. 9, which is a multiplier of 3. So I can accept that this is the center of the enlargement. Everything is consistent. All right, just wanted to make sure. So I did a check. All right, so this point is the center. What is coordinates? Negative 10, 7. On this line is a y value of 7. Negative 10, 7. Negative 10, 7 is the center of enlargement. This point right here in blue. Negative 10, 7. All right, so we can describe it now. You have a center and a scale factor. So single transformation which maps P onto Q is an enlargement of scale factor . equals 3 and center is negative 10, 7. I could say about the center or about the point. Center point is negative 10, 7. So give the two components of enlargement, scale factor and the center. Very good at that.
Yes, sir.
All right. Then we're going now from E to R. This one gives some persons problems, I'm telling you. All right. From this one to this one. Let's look at it. I'm going to take these off so we can leave it, all right? All right. So we want to get now the transformation from this one to this one. So we can get some basic things first. Like for example, you see that this line diagonal in the middle here is pointing down. Corresponding diagonal is now pointing to the right, like this. So like it turn around this way, 90 degrees. One was 90 because it was horizontal first, and it was vertical first, sorry, and it is now horizontal. Again, it's because if this point turn up this way, and it's now pointing so. Just like it is positioned somewhere else. So that 90 degrees anti-clockwise rotation. Problem is, where is the center? All right, so we know it's an anti-clockwise. Think of it again. Now, this point has become this. So like you take this and you turn it up like this, because this now is here. Just like it is positioned somewhere else because the center is somewhere else. The center is not here. Center is somewhere else, right? With an anti-clockwise 90 degrees rotation. So the only thing we need now is to find the center. Well, the center is located on two perpendicular bisectors of lines joining corresponding points. I want to choose easy corresponding points. I have to identify the corresponding points as well. But that's about the corresponding points. So this point corresponds to this. And this point, if we go around to the right on the object, go around to the right on the object. Remember, orientation is not reversing. You know? So if we call this point A, for example, then this will be A. Just giving them a C better for now. This is B, and this will be B. And this is C, and this will be C. This is D, and this will be D. So I'm going to mark some corresponding points now, right? I'm going to leave the letters. So corresponding points, mark them in blue. These two correspond, mark them in blue, Mr. Shaw. These two correspond to each other. And also this one and this one, both of them are D. This one is D. So you have to find the corresponding points. Now, the beauty about these two right now, this one and this one, is that they are both on this vertical line. So you can easy to find the perpendicular bisector of that one. All right. So you want to use easy points, you know, to get the perpendicular bisector. You want to do the mathematics easily. All right. So I'm going to use those two. Let me erase the other stuff that I don't need now. So I already know that I'm going to be using, oh man, I already know that I'm going to be using these two. I get a perpendicular bisector between those two. Let's try these two now, if they're friendly. So if I were to join them by a line like this, I want to find the midpoint. To get the midpoint, I want to break down this length into the horizontal and a vertical. And right now, this horizontal is just 1 unit. I don't want to go halfway of 1 unit. I'm not going to use those 2 points. All right, choose 2 other points to make it easier. So let's try this one and this one that correspond to each other. All right, so I would have to get the perpendicular bisector of this line. But I'm going to look easier because of the components of this line can be looked at as 2 units across here, and then 1, 2, 3, 4, 5, 6 units up here. So it's kind of now easier to find where the midpoint of that line is, because if it's broken down 2 units across, 6 up. Then midpoint is going to be 1 unit across and 3 up. So the midpoint of that line is here. All right, the midpoint of that line, that red line is there. And then I said, let's do the other pair in a different color. So the other pair, I'm going to do it in purple. That's this and this is on this vertical line. These 2 points correspond to one another. That's a line joining them. I need the perpendicular bisector of that line. So I need the midpoint first. How long is it? 1, 2, 3, 4, 5, 6, 7, 8. The midpoint is therefore 4. 1, 2, 3, 4. So the midpoint is right here. 1, 2, 3, 4. Yes. So I know that the center, the perpendicular bisector of this line, now let's draw it in green. Let's draw it in a different color. Let's use green. So the perpendicular bisector of this line is horizontal. As the vertical, so the perpendicular bisector is going to be horizontal. So the center point is somewhere on this green line right now. I also need a perpendicular to this line to this point. Now what you can do to draw it quickly, you could put your protractor on it. Sketch it out for you. Put the protractor on this line, put a layer. Like you put the protractor on this line, the protractor, and then you could measure or locate the 90 degrees. Locate the 90 degrees to it somewhere out here. With a protractor, locate the 90 and draw it. We could also kind of calculate it, all right, using what we know about perpendicular lines. So look at it this way now. Show you we could actually work it out another way. So you remember, you want the perpendicular to this line. So this line has a positive gradient. Rise 6, run 2, right? So the red line is a gradient of 6 over 2. Rise 6, run 2. That's also 3 over 1. So the gradient is 3 over 1. The perpendicular to this is going to be negative 3. Negative a third, sorry, negative 1/3. Flip it and change the sign. So to get a perpendicular to this line passing through this point, we need to rise -1, run 3 to get the line that is perpendicular to the red one. Let's do it in green using our coordinate geometry knowledge. A gradient of 3 and a gradient of -1/3 are perpendicular. This red line has a gradient of 3. So we want a gradient of a -1/3 passing through here. So we're going to rise -1, run 3. 1, 2, 3. That takes us to this point right here, which is actually the center point. And the fortunate thing about it, puts us right on that green line that we know the center is on. So this is a perpendicular of the red line, this one. So I've shown it 2 ways to get that perpendicular of the red line. So those two green lines are my 2 perpendicular bisectors. They intersect here. So that is the center of the rotation, this point right here. Let's put it on in blue or in red. This point right here is the center of my rotation. That is the center of the rotation. That point is -4, 2. -4, 2 is center of rotation. You can kind of draw some lines on it to test it, you know. All right, you can kind of test it. Let me test it for you and show you. Let me take these off momentarily and show you. I'm just going to leave that center point and just show you for now. All right. So if you think of, for example, this point, rotating about here to this point, you can literally see that this is 90 degrees. This point was rotated down to here. If you choose another point, like for example, this point was rotated down to here, which is this one, rotated down to there. You can see the 90 degrees in here. Rotation was over there. So it's kind of showing you that this center point is real. All right, let's see if I can get back what we had before. Right, that's what we had before. So that point is the center point, guys, and the angle of direction is 90 degrees, and the direction of rotation is anti-clockwise. And this is the center of the rotation. But I go with that. If you didn't do it, guys, it's something I advise you to watch over the video and go back through this one and try and do it yourself. The two perpendicular bisectors and locate the center of the rotation. All right, so now that we have those 2 points, we can write the description. Those two things are we have the center point or the angle and the direction. So this is an anti-clockwise (90 degrees) rotation about the point -4, 2. -4, 2. Let's just make sure. Yes, -4, 2, the center of that rotation. That's the description right there. That is it. 3 marks for that. Very good at that.
Yes, sir.
Very good. All right. I'll advise you to go and do this one over by yourself. Let's do 2022. So I have 2 more questions to do. 2022 and 2021. Oh, let's see if there's any on number 10 first. Let's see the transformation question on number 10. Looks like not. It's a straight major series. All right. Let's look at 2022. I think I have it up already. 2022. I have it open up already. This is it. Yes. 2022, question 3. Question 3. Not too far, Mr. Shaw. There you go. This is it. And actually put in question 4. No, question 3, yes. Circle question. Here it is. So the diagram below shows triangle, the prime triangle. So these are like image triangles, right? So they have not given us the object. So these are image triangles drawn on a square grid. So those are image triangles they have given us. It says this triangle is the image of triangle XYZ after an enlargement of scale factor 2 about the center. Wow, I love this question. So to get the original object, we're going to have to go and do an inverse enlargement. So remember, the inverse of an enlargement of scale factor 2 is going to be an enlargement of scale factor half about the same center. So basically, to go from the prime triangle back to the original triangle, we're going to have to do an enlargement of scale factor half from the center point, 5, 1. Center point remains the same, 5, 1. So center point is right here, 5, 1. And we're doing it on this triangle. So to do an enlargement of scale factor half, but understand that the inverse, we have to do the inverse. So the scale factor 2 map you from this one to this. So let's say, no, let's say this triangle, the prime triangle, this one, is the image of our original triangle XYZ after an enlargement of scale factor 2 from this center. And I want us to locate the original triangle. Right? The original triangle, the object triangle they want. So if I go from the image back to the object by doing the inverse of the enlargement. So since the original scale factor was at 2, the inverse, we're going to use an enlargement of scale factor half. Meaning we're going to be half in the distance from this point to that one, just half the distance. That's all we have to do. So let's use, and we know that the dimension is going to be half as well, you know. So we can actually find 1 point, you know, and then draw the dimensions half this side and half this side. And the scale factor affects the distance and also affects the dimensions on the object. So we want half the size and half the distance back to the center. Let's use this point to start. Now, how far is this distance? can break down that distance into two components, here and here, and just half that distance. How many units is this? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and then 2 up. So that's 8 back, 2 up. So I'm gonna half that distance to 4, 1, the way this is gonna come back, or the way this was 4, 1 from here. All right? So I'm gonna half that. I'm going to 4, 1. So I'm gonna go 1, 2, 3, 4, 1 up. So this is where this point was before the enlargement took place. So this point is actually Z. This point is Z. And then now this side, you have to put half of it. So it is 4 units, 1, 2, 3, 4. It's going to be half. It's going to be just this. Because scale factor, you're halving back this dimension than this. This side is 2, the image on the 2. So the original object was 1 to here. So that is the triangle. That's the original triangle. So this point is where X was. This point is the image of X right here. So this point is X. And this point is Y. That is it. What good at that? That's a triangle. I'm putting a construction lines from the center point. Ready. So this one, that one, and the one through here. That's it. Those red lines are construction lines. Those distances are cut in half to bring you back to the object. But the image was on a scale factor of 2. So to go from the image back to the object, you have an enlargement of scale factor half from the same center. Everybody gets that. You guys have that? You guys understand that?
Okay.
Yes.
So this was the center point 51. Okay, good. I will do an enlargement of scale factor half to bring it back. All right, and that's why in class I keep talking about the inverse transformation, as I said, it's common sense, the majority of them. All right, so this one, apply that. This one now says that triangle, the prime triangle is mapped onto the double prime triangle. So we're now going from this to that. All right, by reflection in a line P. And I want us to just tell them the equation of that mirror line P, the equation of it. So we're going from this to this by a reflection. We just need to find where the halfway mark is between, for example, these 2 points. When there's a vertical line, and obviously, this horizontal piece is reflecting the horizontal line to the horizontal, right? Not vertical line, sorry, to the horizontal. We need to know the halfway mark between these two. So this is 1, 2, 3, 4, 5, 6. It's going to be 3 from either one. So it's 1, 2, 3. So it's talking about this line. This line. The mirror line. You can check another point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to Z. So that line is a mirror line. What line is that? It's a vertical line passing through 2, which is 2 on the x-axis. So it's x equals 2. Is that mirror line? X equals 2. So the access for the equation of it, that's it. X equals 2. X equals 2 is the equation of that vertical line. That done. Any questions on that, guys? Are you okay? Everybody good? Inverse is 3 equals half. For the inverse, 3 equals half. So when I say use the inverse here, use the inverse enlargement is equals half on the same center. All right, that's what we used to go from the image back to the object. We use the inverse, and the inverse will have a scale factor of a half from the same center. All right, let's see if there's any over number 10 for this paper. As you can see, sometimes you get two transformation questions. this one was straight major series. But this is a transformation, really. It says transformation T maps this, which you should know, from this point to that point. And I ask him to describe it. It's easier to just know it. That's a y equals x reflection matrix. And you should know because if you notice, coordinates are reversed. 2, 5 becomes 5, 2. So that's a reflection line y equals x. A reflection in the line y equals x. All right, I will know that line from functions as well. Because remember, in functions, this point will map to this point by the inverse. All right, the inverse would basically reverse the mapping. So if you map 2, 5 back to 2, 1, and the relationship between a function and its inverse, you have reflection line y equals x. So we start to see the connection now between what we learned in functions and what we're doing now in transformation. But that is that. That was all the functions, transformation and that question. Let's look at 2021. I never call it a day. 2021. 2021 is to show. 2021. 2021. Let's see. Number 3, as usual. There you go. All right. This one says, letter E and the point C66 are shown on the grid. So this is the letter A. That's the point C66. We're not going to do an enlargement from C. All right. It says, on the diagram, draw accurately each of the following transformations. An enlargement of the letter E by a scalar factor of 2 about the point C. So if we apply a scalar factor of 2, we're going to have to double the size of the A, but we have to double the distance from the 6. You see, that's how you have to do it. You have to know that this 2 affects the distance from this point as well. Now just doubling off the side of the A. So you're doubling the distance from 6. So let's look at it. So this is the center. So for example, this point, we want this distance to be doubled. That one kind of easy because just 2 diagonals. So to double that distance, we go across 2 more diagonals. So this point is coming to here. Right? That will double it. So that is it from here coming to here. All right, let's do another one. Then to this point, this distance needs to be doubled. That distance needs to be doubled because of a scale factor of 2. What is that distance? Let's break it down. That distance can be broken down as 1, 2, 3, 4 down, 1 back. So to double that distance, that's 4 down, 1 back. So to double that distance, we're gonna go 8 down, 2 back. We're gonna go 8 down, 2 back. Or you can just do another 4 down, 1 back, you know, to get that additional one. But we can go 8 down, 1, 2, 3, 4, 5, 6, 7, 8, 2 back, 1, 2. So this point is coming to here. Okay, I'll show it to the line as well. Extending that red line to there. So these 2 points are 2 points on your enlarged area. And then we can just figure out the rest. You can figure out the rest because, okay, now, this width between the tail of those 2 legs on the A 2 units. It's going to go to 4. It's going to go to 4. 1, 2, 3, 4. So this point is coming to here. To here. So those 3 points represent where your A, those key points on the A would be. So it's this to this. So that's what we have so far. This and that. Then now let's talk about this cross piece. It looks like it's about 1 unit from the vertex up here. Not quite 1 unit, because a little bit above, a little bit less than 1 unit. And so it's going to go now 2 units. So this is 1 and that. It's going to go about 2, but a little bit less than 2, you know. So it's going to be somewhere down here. But in addition to that, everything important. So this little gap here that I'm shading out in blue is also going to be doubled. All right, everything important. So it means that the 2 units on the A, bringing it down to about here, where the gap is double. So I see it's going to come about here, that cross piece. So that this length from the vertex down is about twice what this is. So 1, this is 2. We're not quite 2, not quite reach this horizontal piece. All right, so we just want to make everything consistent. But that is it. That's my image A. What about that?
Yes, sir. Yes, sir.
Draw construction lines to check it. Those. And then the next foot through here. And then leave this cross piece through here, there, and through here, there. All right, you can use your ruler and take it, but that is it. All right, that's enlarged E. Then they want us to do a translation on the original E, -3, 2. -3 means starting from points 3 to the left, it's -3. That 2 means 2 up. So moving points 3 to the left, 2 up on the E. All right, so the same shape there is going to be same size, everything. So again, we just need to move 1 point and draw about the same shape around that point. Let's move this. Let's move this one. This one. So it's minus, let me see that again, -3, 2. -3, 2. Let's do this point and just draw about the rest of the shape around it. So it's 3 to the left. 1, 2, 3 to the left. 2 up. 1, 2. This point is coming to here. Put on blue. So this point is going to be 2 across from it still. Here. And this point is going to be like 2 above this horizontal line in the middle. Up here. Same shape A. And then this horizontal piece is going to be a little bit above the halfway line here. So like around here, you can clearly see a gap. Everything important. Don't draw it on this line now. Be observant. It is not on this halfway line. It's above it. So make sure, again, mine is also above this one, not on it. Draw that on 6, you will give it your marks. That is your image. That's what they're looking for. Want to go to that?
Yes, sir.
All right, beautiful. All right, let's see if there's any on number 10. Let's finish that one. All right, let's see if there's any on number 10. And then we'll call it a day. We'll pick it up back tomorrow and Monday. Make sure everybody bring your ruler, a pencil, and you bring your hand out. You will not come to class without them. You're going to need them for the activity that we're doing in class. So this one now is not transformation. It's just straight matrices. So this part is transformation. All right, this transformation. Let's see. It says a right angle triangle, these coordinates. All right. So right angle triangle M at these coordinates are the vertices. All right. The triangle is called M. But triangle M has these points as the vertices. It says when the triangle M is transformed using this matrix, and nobody know that matrix is. This is a y equals x matrix. The more things you know, the better. What it does, it reverses coordinates. This is a y equals x reflection matrix. Reflection. What does it do? It takes a point xy and it maps it onto yx. It becomes easy when you know these things. This is the y equals x reflection matrix. And it maps it onto an image point. Your question says, find the coordinates of M prime. All I need to do is reverse these coordinates. I'm done. More things you know, the better. So x prime, we reverse 1, 1, it's going to stay 1, 1. That's x prime. This point y prime, let's reverse the 3, 1 and get 1, 3. And then z prime, I need to reverse the 3, 4 and get 4, 3. You cannot be penalized for advanced knowledge. If I put this on the exam paper, they see where I'm coming, where I get my answers from. I don't need to show the calculation because of my advanced knowledge. I know that this represents a y-axis reflection, and I know how the y-axis reflection works. It reverses the coordinates of a point, and so these points, the coordinates are reversed to these. Once I put this is my justification for my answer. They have to give them marks. I don't have to calculate it. But if you want to show some calculation, let me show you what you would do if you wanted to show some calculation. We'll put it in purple, a different color. So we'll say, or if you want to calculate it, you can use the matrix 0, 1, 1, 0. I'm going to multiply it by the 3 points in one matrix, x, y, and z. The x is 1, 1 under here. The y is 3, 1 under here. And the z is 3, 4. And you're going to get back your image matrix, x prime, y prime, z prime. Let's make this a little wider. And like you have 3 matrices in one, 3 column matrices in one. That's what this is. It's not really a 2 by 3 matrix, this, guys. It is really 3 2 by 1 matrices in one, 3 column matrices just put together. Right? If you want to show some calculation. And then we're multiplying them out, right? So this row times this column for the first value up here. It's going to be just this 1 while it's switching around. It's going to come back to 1, 1. And for here, it's going to be this row times this column for this value first. It's going to give me the 1. So it's going to be 0 times 3, which is 0. And 1 times 1, which is 1. And then it's going to be 1 times 3. And 0 times 1. But once I see that the calculation actually switch around the values, I know the calculation will also switch around these values. I don't have to actually do it. Because the matrix will do the same thing to each point. So maybe I wouldn't see it with the 1, 1, you know. But I can clearly see it with the 3, 1 that it turns it into 1, 3. So it will also switch around those values, 4, 3. And then this is not the answer. Then I have to go and write the x prime as these coordinates 1, 1. The y prime has these coordinates 1, 3. And the z prime has these coordinates 4, 3. What I'm telling you, I would do in the exam, what is in blue. the exam, you get the 2 marks easier. More things you know, the better. There are some things you don't need any calculation for. Because if you know that affecting line y plus x versus the coordinates, then you just give them something to say that is your reason for giving an answer like this. You tell them what matrix it is. So affection line y plus x, you tell them that it works this way. And hence you are able to just write down your answers like that. And that will be it. I think that finishes this session, guys. This finishes this session today. Hope you rework the questions to all of them. I'm going to send some more questions to the group after the class tomorrow. Any question you didn't get right, make sure you go and do it. Any questions you did not do, make sure you go and do it. I'm going to send the video in the group right away. So work through all the questions, use the video to help you so that these are not difficult. They're actually very easy. And they'll become even easier once you start learning the items on the must-know sheet that I gave you. All right, so see you all in class tomorrow on Monday, guys. Have a great day.
Bye, sir.
Okay,
Later,
bye-bye. Yes.
sir.
All right, bye-bye. Bye-bye, Jaden. Bye-bye, everybody. I'm going to end it now.